Hello, ladies and gentlemen, and welcome to this episode of Developing Classical Thinkers. My name is Winston Brady, and I'm the host of DCT. This podcast is a project of the faculty at Thales Academy. We're a network of private classical schools with campuses mostly in Raleigh, North Carolina, but we also have campuses outside of Richmond, Virginia, Nashville, Tennessee, and Charlotte, North Carolina, with more coming on board each year. Since this podcast is a project of the faculty at Thales Academy, I'll bring on teachers across our network to share their best practices with other like-minded classical educators and with our parents. On today's episode, I've invited Ms. Kim Tully to join us to talk about the Luddy Industrial Arts program at Thales Academy. Kim, thank you so much for being on the program today.
It's a pleasure. Thank you for having me.
So Kim, could you give us just a high-level overview of your role at Thales, how long you've been teaching here, and the type of role that you have right now?
Sure. I'm a chemical engineer, and I was first employed by Thales about 7 years ago in the role of an instructor in the Luddy Institute of Technology. That's a program that they have for 9 to 12 graders, which teaches them the fundamentals of engineering, woodworking, electronics, programming, mechanics. And we graduate students who then go on to some of the finest engineering schools in the country. So I was doing that for about 6 years. And then Mr. Luddy introduced Luddy Industrial Arts, which is a program for middle school students, which leads up to Luddy Institute of Technology. So I was really enthusiastic and excited about that because I could see how engaging those younger students in the field of engineering at a very early age would open their minds to all the possibilities they have studying and going to university and the careers that they could have. So I jumped on board with that, and now I work on the curriculum for the Luddy Institute of Technology and Luddy Industrial Arts and Luddy Vocational Arts.
And it's a huge role, but you've done an amazing job really guiding, overseeing, shepherding this program, its students and its teachers. So at every campus, we have a classroom dedicated to Luddy Industrial Arts, and 6th grade through 8th grade students are learning some of the basic fundamental skills of engineering. Would you talk about just your vision for the program and the types of skills students are going to be learning in 6th grade? Well, really that they're learning now in 6th grade, and that will continue to roll out every year, every grade level, the new skills. We've got some of the books that you guys have written as well, and these are just beautiful. I love these. I love showing these off to parents, to teachers. It just makes our program look amazing.
Well, it's actually not my vision. I have to say it's the vision of Mr. Luddy, who understands how important it is to teach students to solve problems and be able to solve problems with their hands in practical, real-world scenarios. So I'm so excited about that because it's so easy to teach kids, all the other subjects we teach them at school, and then they get home and they have a simple problem and they're like, I don't know how to fix that. Oh my word,
yes. I don't know if that happens around the Tully household, but when something breaks at the Brady household, I despair for a moment, and then I get on YouTube and I start searching and trying to find a video that closely mirrors the problem that I have.
Well, it's a little bit different at our house. It's usually my husband who's despairing as I'm putting all the pieces of the toilet on the floor and saying, don't worry, we can fix this.
But you've got the design process. Like, how this iterative process is supposed to work as far as solving problems.
And that's what we're trying to teach the students. So if you look at the curriculum starting in the 6th grade, we teach them the engineering design cycle. And I always laugh because I tell the parents, actually what we're teaching your children is how to fail. Because if you have ever dealt with 6th graders, you know that when things don't go the right way, they tend to cry. So when you teach the engineering design cycle, you teach students that failure or the inability to get to the solution immediately is part of the process. So
it's supposed to be iterative.
Exactly.
Can we go through the design process too?
Sure. Well, actually, it's in all our books. I'll show off some of our pictures if you like. We have some new cycles coming up, but it's all about trying to figure out what the problem is, and then imagining the solutions that you can and planning them, then creating your solution and testing it, and then trying to figure out what are the ways that you could improve your initial solution. So students are not used to the failing and testing and reimagining portion. They start in the 6th grade thinking, oh, I've got an idea, and then if it doesn't work, it's like, oh, I failed.
I must not be any good.
Exactly.
Right?
So what we want to teach them is actually no, it's not failure. Not getting it right the first time is part of the process, the iterative process, as you pointed out. So by the time the students get to the 7th grade, they're so comfortable with themselves. They'll come up with ideas and solutions that they might have been too shy to try in the 6th grade. But then they realize, oh, that's okay, because if this doesn't work out, I am going to use that as data and look at what went wrong and analyze what went wrong, and then try to figure out how I can approach it better. So by the time they get to the 8th grade, they're stars. They know exactly what they're doing. So.
And in 6th grade, so we've got fundamentals of engineering, right? So students they're learning the design process, how to measure, how to use particular tools. Yeah. And then I love the project that you have. So I'll let you describe it. I won't take your thunder. What's the project that students are doing as part of 6th grade fundamentals of engineering?
They're building a hydraulic robot. And by the time they get there, they have learned quite a lot about the basics of engineering. They've learned, we teach them isometric and orthographic drawing, because obviously when you have a good idea, you need to then be able to tell people and explain what your idea is, and you need to be able to communicate.
And isometric drawing, orthographic drawing, these are ways of taking a 3-dimensional object and putting it down on a 2-dimensional space, your paper.
Exactly.
Right? Okay.
So that if you have a great idea, you say, okay, can you please draw this out for me? So they'll draw out their ideas, and you can look at their ideas and say, okay, well, maybe you want to adjust this a little bit, or think about it this way. Are you going to have a problem with this, that, or the other thing? So communicating their ideas is super important. And so we get through these early engineering fundamentals, and then we take them through strengths of materials, center of gravity, different types of friction, forces such as friction, and they design and build a hydraulic robot, which they get quite excited about, because at the end there's a competition to see whose hydraulic robot can knock the other guy's hydraulic robot out of the square. So it's a competition, and they're trying to build robots that are not going to fall over. So it's super fun. Yeah,
and it's such a good project for kids to do in 6th grade, because it's mostly popsicle sticks. It's syringes, tubing. I mean, things that are like safe as far as giving kids. But I know they use a lot of tools that are, and you emphasize safety to the utmost degree.
Safety is definitely our top priority, but I have to stress that 6th graders are capable of doing an amazing number of things. In our woodwork, we also teach a unit on electronics, where they learn how to wire things together.
Do they do any soldering?
No, not in the 6th grade, I do confess.
Are they just using breadboards?
They're using breadboards and all the components and batteries, and so they learn what resistors are and how to measure voltage with a multimeter and these types of things. And then we also do a woodworking unit, which is fantastic. They learn to use a saw. We use miter boxes, and they learn how to use a drill, a proper DeWalt hand drill. And they learn how to use screwdrivers, they learn how to put in fasteners, they learn how to measure, they learn how to make sure that things are straight and flat. They make a beautiful iPad organizer out of poplar. So they have something nice to take home. So it's amazing what you can teach young students, and they just love it. I mean, you put a hammer in the hands of a young student who's about this tall, and they say, oh my gosh, Miss Tully, I don't think I can. And by the time they finish the course, they have so much confidence, and they're so empowered in their ability to solve problems. In the 7th grade, they use a bandsaw, they use drill press, so they do learn to use quite a lot of tools by the time they complete middle school.
I think Aristotle would be, I don't mean to bring up Aristotle so early in our conversation, but I think Aristotle would be so excited with your program, Mr. Luddy's vision, and how you translated that into classrooms across the Thales network, because the students are learning such valuable knowledge, such valuable skills that they can use to build like a real product that they can take pride in. That's one of the when Aristotle talks about activities that you do for their own sake because of the joy that they bring the person who participates in them, it's a nice definition for the liberal arts. He does include within that artistry, craftsmanship, a body of knowledge that accompanies an activity that produces like a final product. I've seen kids carrying around their iPad holders. Like they've got this pretty bulky wood iPad holder, but they bring it with them to every class because they made it.
Yep.
Like it's an expression of who they are. It's a nice little reflection of the personality. They've got some stickers up there, but you've taught them how to build, how to take random disparate pieces of wood and bring it together so that it serves a vital function, helping them stay organized.
Well, and one of the nicest moments I can remember in the past year is an email I got from a parent. Mm-hmm. And it actually had a photograph, and it was a young student who was in the 6th grade, and she was down on the floor in her garage with her father. Mm-hmm. And they had all these wooden pieces there. They were building something. And apparently the dad was going to do this project. And his daughter said, well, I know how to use all these tools. I can help you. And I thought, yes, that's exactly what we're looking for. So, and it's amazing to see the confidence that they get when they learn these different skills. And I think that's marries so brilliantly with the classical education, and we teach them to explore with their minds so many different aspects of life, but then at the end of the day you also want them to understand the more practical aspects of the life around them. We just started working on an auto repair unit, and we usually build we have learning boards that have actual parts of a Toyota Corolla on it.
How big is the learning board, though? Can it
it's
fit in the
pretty
classroom?
big.
Okay.
Yes, it fits through the door. We were careful.
Do you need cars to work on, in case?
Well, right now we're working with learning boards, and we have one that was designed by one of our interns, Nolan Sawyer, and he's just done an amazing job. And it's got the brake and suspension system. And we did a pilot in the classroom, and Nolan actually taught the pilot. He's a senior at Thales, and some of the 9th graders were actually changing the brake pads on this learning board. So to see them understand how the mechanics of their car works, and to get in there and change the brake pads, it's an amazing thing to see.
I mean, and that's like a $250 repair right there. So you're teaching students such a valuable skill that can benefit them and really their family for the rest of their lives.
Well, even if they may not decide to actually change their own brake pads, but at least they can have an informed conversation with a professional who might be doing the job for them, and it makes it easier for them to communicate and not be taken advantage of, for example. So some will opt to do their own repairs, where our next unit is teaching them how to change their oil. So that's a pretty exciting one too.
Yeah, I mean, it's so nice in this day and age. A lot of students, classes I've taught in, they would rather take Uber, from one place to another. Like a lot of students, this is kind of a generational shift, but they're choosing to not have cars. They're choosing to not own homes because it's so difficult taking care of those things. It can get so expensive. What you're offering to students and the sorts of practical skills is doing so much to like reverse that particular trend.
Well, one of the things that we're doing, and we're preparing for our 8th grade curriculum, which is got plumbing aspects to it, is we've got some learning boards that are actually acrylic and have the insides of the toilet on the back. So that they can actually learn how to change that. Now, I don't know about you, but my plumber charges $250 just to knock on my door.
I know, it's so funny.
So it's like you can do that with like a $25 kit from Lowe's. You can change the inside of your toilet if you have a little confidence. And see, that's what we're trying to teach them. That they can say, oh, this is not working properly. Oh, I probably need a new one of those. I know where I can get it. I know how to do that. Boom, I just saved myself like $350.
What do you think about students entering into like trade schools, technical schools after high school? Because we place this distinction between like high level academic jobs like being a lawyer versus like being a plumber. But like ironically, in this day and age, the plumbers are making as much, if not more, than many lawyers out there, since there's so few good plumbers.
Absolutely. And if you ever have to call a plumber or have to call an HVAC repairman or anything like that, electricians, the waiting list, the time it takes to get professionals into your home is an indication of the fact that there just aren't enough of them. And it's really not fair to say if you go to engineering school that makes you more professional or more educated than if you go to trade school. People who go to trade school are learning just as many valuable skills as somebody who opts to go to engineering school. And they're all engineers, and people who go to trade school work with their hands.
Yeah.
So I love seeing students opt to go to trade schools, because it used to be that if you said, oh, I want to go to trade school, people would look at you like, why does that mean that you don't, you can't get into university? But now it means that you're opting to do it because you're choosing it, because you enjoy it, and because it is all of the trade school professions are highly respected. So I think that we must all go to university attitude has shifted quite a lot, and I think it is due to shift more. And I think it's a good thing, because let's face it, if you go to college doesn't necessarily mean you can fix your toilet, and vice versa. But the world has to have some balance. We have to have, the right skills to survive as a society. And a large number of the very valuable professions are across the trades: carpenters, electricians, plumbers. I mean, we can't live without them.
I mean, I don't know about you, but if my son if my son were to tell me, Dad, I want to go and be an HVAC repairman, like, I would be so happy.
I'd be so excited.
Right. I would get free air conditioning service for the rest of my life. So yeah, please, go ahead and do that. And it's such a good, in some ways, that is such a responsible decision to make. Like, I know what I want to be.
Exactly.
This is financially viable. Like, I can make this work. I can take care of my family, and I can really bring a lot of value to the customers that I serve.
And those are very high paid professions. And not only that, anybody can go to work tomorrow and get fired because of some shift in the economy or a shift in what consumers are buying. But you are always going to need electricians and plumbers and carpenters and HVAC repairmen. These are the people society cannot live without. So there is excellent job security. And in auto repair, look at the people who study auto repair now. They have to know electronics, they have to know computer science. I mean, these are such advanced fields now to be able to work on the kind of equipment that they have, especially in HVAC. If you even look at some of Captive Air's HVAC systems, they're super complicated, changing constantly, lots of computers, lots of electronics. It's amazing.
I love to, bringing it back to Mr. Luddy's vision for the program. I've heard him say oftentimes that if you can't change a light bulb, you really can't change anything else. If you can't change a light bulb, you're definitely not going to change the world. It's about teaching students valuable skills that they can use to take care of themselves and their families. And there's such a deep, classical precedent for this type of education. I mean, Paul and tent making, right? So the Apostle Paul, during the day, he would make tents. That's something that he could sell to people that they needed. I don't think it's camping tents, but whatever. Socrates was a stone cutter. Jesus was a carpenter. There's such a valuable precedent for learning a trade that you can use to take care of yourself and the people who are around you, but also filling your head with that valuable head knowledge. For Paul, the Apostle Paul, the scriptures, a degree of Greek philosophy, but the Old Testament law, and so on. But that way, you have something to do during the day that you can bring value to your community, and then at night, you can find great enjoyment reading a book or engaging in really deep and meaningful conversation.
Absolutely.
Your program here is so good for producing more tent makers, stone cutters, carpenters, and the like.
Well, I believe it's about awakening the desire in people to do things with their hands and to solve problems with their hands and learn to fix things, repair things. But it's also about giving them options and making them understand more of the choices that they have in their life. Because I think if you do get exposed to an industrial arts program, you're more apt to look at the possibility of becoming an electrician or of a carpenter. You might the kids walk in the class and say, "Oh, Miss Tully, I just love the smell of wood."
Me too.
But you probably didn't even know that until you walked into your industrial arts class.
Yeah.
So it is amazing. And I have to stress that the program it has been an amazing team effort. A lot of the work that we do is done by students. So if you were to look at this book, for example, this was, and this book as well, these projects on the front were built by students. This is a prosthetic hand, and this is a 3D printer, and they were built by seniors in the LIT program at Thales. And the contents of the book and the format and everything, these were done by students at different schools in the Thales system. They've learned how to do the InDesign, they've learned photography as part of an internship program there, but they've actually authored these books based on the skills that they've learned in the classes. So this is another aspect to the industrial arts program, is the fact that we employ a lot of interns to do the work. So it's you know, people say, oh, you're doing amazing things. Actually not. There is just a massive team of people that worked so hard to pull this all together, and most of them are under the age of 18. They're hardworking, you know, students who are putting their hearts into, you know, getting other students excited about the possibilities.
Well, there are deep classical precedents for that too. I mean, George Washington had a job as a surveyor in his teenage years. I mean, he was on a horse, riding through the Virginia countryside, taking measurements, making maps and the like. So, I mean, these kids are, they love it. I mean, I see them, I show up random Saturdays, random, you know, afternoons during track out breaks, and they're taking photos of tools, you know, they're writing materials, just really high quality curriculum that you guys are putting together as part of your team. So we've got fundamentals of engineering, fundamentals of electronics, we've got fundamentals of woodworking coming out soon.
Yeah,
and
then we have, we're also launching pollinators, organic gardening. We are working right now on plumbing, household repair. We have our auto repair unit is going to come out next year. And we're also working on a new series, which is the Luddy Vocational Arts. And right now we're going to be launching next year, this coming academic year, actually, navigation. And it's funny you mentioned making maps, navigation and the science of cooking and nutrition, and also mechatronics, which is robotics, and programming. This is for the 8th grade. They'll be programming small robots in Python with block coding. And we're also doing a fantastic sewing unit.
I love the sewing unit. I mean, we worked together for a long time developing these things, but like everybody should learn to sew. Like if a soldier in the South Korean military has to learn to sew, like everybody should learn to sew.
Well, they're doing some great projects, so I think they're going to really enjoy it.
Pot holders?
No, well,
no pot
they're
holders?
going to make a locker bag that they can hold their belongings in their lockers.
That's more practical.
They're going to make a key fob, and then they're going to learn very fundamental skills like how to sew seams. They learn how to use sewing machine. They learn how to sew on buttons. They learn how to do some hand sewing, learn how to patch their jeans. And there's a lot of creative aspects to it. So in the culinary science, in science of cooking, they're going to be learning about the 10 primary chemical reactions, and that's my love of chemistry there, that take place when you're cooking, and they're going to be doing a lot of cooking some pretty cool things. We're doing a lot of really nutritious foods. But for the fun of it, I had to throw in gummy bears. They're going to make gummy bears with all natural flavors and colors that we extract from different fruits and vegetables. So it's pretty exciting. I
know Mr. Luddy was really excited about that. He did on Bob's book review a review of the Whole Foods diet, and there's a lot in there about blue zones. So which is really fascinating. So there's a number of communities, but so Sardinia, Okinawa, Linda Loma, California, oddly enough, and a handful of other places that because the people who live there exercise very regularly and eat, you know, almost no processed foods. It's just all like, you know, all whole foods.
Whole foods,
yeah. Really, Mr. Luddy really wanted to build that into the curriculum just to give students more, options for a healthier lifestyle. Healthy mind, body, and spirit, one of our Thales outcomes.
Yes, we're teaching them to cook a few meals that they can prepare for themselves. Because the idea is, like, we're sending these kids out to wherever they're going to their next steps of learning, whether it's a trade school or whether it's on-the-job training or whether it's the military or whether it's university. But let's face it, they should be able to sew on a button and make themselves dinner.
Yeah.
You know, these are fundamental skills. And funnily enough, a lot of kids end up at school or out of the house in their next step, whatever that happens to be, and they can't do those fundamental things.
I mean, when I pop a button on a shirt or something, it's like game over for that shirt because I can't sew. I didn't go through a class that taught me how to sew.
We're going to teach you.
We got to do that. Okay, can I be the dummy to learn how to sew?
We'll teach you. You'll be our pilot.
Okay. If you can teach me how to sew, I think that would be, I need to really volunteer these services too for the fine arts program so I can learn how to sing. I'm not very musically talented either. I need to sing, I need to sew. Is there anything else that I need to do?
Well, we can teach you how to change your brakes and how to sew.
Okay.
We can teach you how to make a meal, how to fix your toilet. So I think we got you covered.
Okay. I do change my own oil. And I do like woodworking. So
There you go.
I try to jump at anything that my wife needs built around the house. Like, yeah, I can do that. She's like, are you sure? Yes.
See, you've
I can
got
at least try.
confidence.
Yeah, you need that in order to tackle these things.
You do, absolutely.
So Kim, can you just tell us, like, who are you? You know, where'd you go to school? Where'd you grow up? Where did you develop these skills that now you can, you know, train students to write curriculum like this? You can unlock this vast, you know, opportunities for students across these programs that you're overseeing. Like, just tell us more about Kim Tully.
Well, I'm a Navy brat. My dad was career Navy, so we moved around a lot when I was young. I was born in Naples, Italy, on a Navy base there.
Oh, che bello.
Yeah.
Ti parli l'italiano?
No, not at all, but I do speak Greek.
Okay.
So then then I went to University of Florida and in Gainesville and studied chemical engineering and concentrated on computer science with my extra hours there. So so I just love fixing things and repairing things, and I love doing things with my hands. So when I moved to North Carolina, I started teaching when I lived on the island of Cyprus for 20 years, and I started teaching there. And when I came to North Carolina, I wanted to continue teaching. So I was just substituting. And they said, well, we're looking for an LIT teacher, but you need to be an engineer. And I'm like, I can do that. And then I just fell in love with the whole program. So that's how I got involved. And there's nothing more exciting to me than seeing these kids fly. I mean, it's amazing how much enthusiasm and excitement it creates, this ability to be able to do things with your hands.
How disparate are all the engineering sciences? Chemical engineering, software engineering, mechanical engineering?
Right. The breadth is huge. I mean, and this is, if you look at the Luddy Institute of Technology, for example, we don't have the time in the 4 years the kids are in high school to focus on one discipline. So what we try to do is give them a little bit of a peek at everything so that if they want to be engineers, they have an idea what they like. So for example, they learn mechanics, which goes along with mechanical engineering. They learn how to program in Python, which points them towards, you know, computer science or computer engineering. They learn electronics, which obviously points them towards electrical engineering. And obviously everything's tied together with the engineering design cycle. They do a capstone project where they plan a solution to a problem of their choosing, and they have to present that in order to get funding, which the school provides for them to buy their materials, and then they build their capstone project. These were 2 capstone projects. So they get like a peek of different areas of engineering so that they can sort of say, okay, I like this, not so fond of that, prefer that, and then kind of narrows down their life choices.
Mm-hmm. The capstone project too is phenomenal. So it's tied into our senior thesis paper. All seniors, in order to graduate from Thales Academy, have to write around a 15-page research paper. The LIT students can have a shortened paper, but they have to complete an engineering project.
Yes.
So we've got the 3D printer a student made last year, 2 years ago. I'm blanking when that student graduated. One of my favorite ones, though, was an automatic pancake maker. So it would drip down pancakes onto a hot pad. It was like a mix of a 3D printer and a mixer. I thought it was just the most brilliant idea ever. I don't know how that is not on the market yet. I would have given funding for that.
Actually, I think that what he had been researching was how they want to produce food in space.
Okay.
But it was a 3D pancake printer, which was amazing because they were obviously edible. They do come up with quite a few amazing projects, and their ability to dream up what they want to build is it's just incredible. I mean, they come up with so many ideas that are just things you would never think of, and you think to yourself, okay, these are the people who are going to be for the next generations, inventing the things that we're going to use to live, you know? So I'm always telling them I'm going to be like super old really soon, so I need a good wheelchair and all that kind of cool stuff. I want it to be all remote controlled and everything. So build nice stuff for me. So.
Have you ever recited to them The Cat and the Bell, one of Aesop's fables?
No, I have not.
The mice want to figure out a way to alert themselves to the presence of the farmer's cat.
Yes.
And one of them's like, oh, why don't we put a bell around the neck of the cat? And everybody's like, that's a great idea. We should totally do that. Because when the cat gets near us, the bell will ring and we'll know it's trying to sneak up behind us. And then somebody points out, who's going to put the bell around the cat's neck?
Yeah.
So it's easy to think of impossible solutions, but you're doing so much to not only inspire them to think of those kind of game-changing, you know, really out of the box sort of thinking, things that are a little bit impossible, but bring it down to earth in such a way, like sketch it out on an isometric sheet of paper. Give me a materials list. Let's figure out some way to make this project, which seems impossible, come into being.
Well, by the time they finish their capstone project, they've done just what you've said. I mean, they've come up with a problem, they've planned a solution, they've done all their drawings, they've done all their research, they've figured out all their components, they've made their shopping list, they figured out how to budget their time, budget their money, and then of course all the iterations in the engineering design cycle, the failures, and trying to get it finished in time to make their final presentation. So they are very well prepared for anything that might come up where they have to actually make presentations and sell an idea for example on any topic. So it is something.
And every year those students present at like a special sort of science fair that we have just for the 12th grade LIT students, so they can show off their capstone projects. I mean, kids last year built one student built an electric guitar on his own.
He 3D printed
an electric guitar.
And he
but he wired it.
Well, he now I'm not going to get the phrase right, but he built in some parts of an electric guitar that are usually on the floor into the guitar that allows you to record different sounds and mix them in. It was
like a wah-wah pedal?
It was, I'm not musical, but it was absolutely amazing. And somebody built a absolutely stunningly, he called it a shable. It was a table that would then, it was a bookcase that would then fold out into a table. It was gorgeous.
Those are really complicated. Every year, there's always one student that will combine woodworking projects into one. So you'll get a fold-out bench that then becomes like a bookshelf, as you said, or like a climbing wall. So
this year we have two really good woodworking projects coming out. One is a variation of a tool bench. It's like got layers, and it's got it's almost like a train of tool holders that move around so that you can have access to a wide variety of tools with ease. Another one is a beautiful tambour. It's like a coffee table with tambour doors, and when they close, there's a beautiful mosaic pattern on the front made out of wood. So it's really beautiful.
Oh man, that's amazing.
Yeah, there's quite some good projects coming up this year.
Can I share my favorite Kim Tully story?
I'm afraid, but go ahead.
Oh no, this one's great. So I remember it might have been last year or the year before. I was traveling around to like various campuses and doing coaching and modeling, and some of the industrial arts classes. It was the problem of storage. So everybody had ordered a closet that you had given them, like the spec number and so on. And so everybody was like, and I said, there's a problem with storage. Everybody's having a hard time like storing tools, storing projects the kids are working on. It just seems there's got to be some room for improvement here. But I kept hearing, well, they have Kim Tully's closet. So there shouldn't be like any sort of, there shouldn't be any sort of problem here. But I looked in your closet, and your closet is completely different. Like, you tricked it out with pegboards, with shelving, everything that you need to hang tools. The closets that the other campuses had were the same closet, but they were really for linens. They were for like towels and sheets and things like that. Your closet was totally different from anything else that I'd seen across the network. So so thankful that you're in this position to outfit these rooms according to the specifications that they need, to develop teachers to teach students how to use these tools and to maintain the highest levels of safety. Can we look at your closet though? I've got some photos of your closet here in Rollsville. So I need you to tell me what all of these things are for.
Well, this isn't the closet that you're talking about.
Okay.
That's the closet
so we can start here. So
basically, what we did was we just stripped everything out of the closet.
So you took out all of the shelving, typically used for towels and linens.
Then we went to all
They
9.
don't make a closet like this for sale.
So then we went to all 9 schools and we did the same thing. We stripped out all the contents, and the interns custom built all the pegboard inserts, and we ordered all of the tool holders that go in there. So for every tool that the middle schools and the high schools have, which is a lot of tools, there is a place for everything, which is our motto. We want everything to have a place so they can stay nice and tidy. So, because that ties into safety, obviously. You want your drills in the right place. You want your hand routers in the right place. So we just stripped them all out and then refitted them with everything. And when you open them, it's like a mini hardware store. It's really great.
How many drills do you have here? How many does a normal class need?
12.
12. Okay. Is that one per every 3 students?
Class sizes are very manageable at Thales. So we have 12 drills. We actually we choose the number of a tool based on how many students a teacher can realistically watch with that tool at one time. So at this level where we have 12, say in the 6th grade, who are using drills, you would typically have a teacher and a teaching assistant watching them all at the same time as they learn how to use them. So, for example, there are 2 or 3 hand routers, because an average teacher can actually safely watch 3 kids on a table at a time. The rooms are custom designed for the industrial arts and LIT curriculum. So the tables, the drop-down cording, all of the closets in the schools have all been fitted out. And everything is organized and labeled so that teachers can find things easily. And all the schools are the same. So if you go from one school to the other, you should find the same setup, which makes it very easy for students and teachers. So it's all based on engineering in the sense that it should be tidy, it should be organized.
Should be rational.
Yeah.
I love too the formula that you have. So we can have more drills because that's a relatively safe tool, but we're only going to have 2 hand routers or 2 jigsaws because those tools are those are much more difficult to use and to ensure
so the high
students use
schools
them
will
safely.
have, for example, 4 or 5 jigsaws. And by the time the kids get to high school level, I mean, they learn how to use a jigsaw in the 9th grade. By the time they're juniors, they know how to use table saw, the miter saw, drill presses, band saws, circular saws, hand routers, table routers, jigsaws. I think we already mentioned that. All the obvious staple gun, nail gun. We have so many tools. They can do joints with pocket joints and dowel joints, and they have a lot of skills. These kids have a lot of skills. So, and by the time they get out of the 9th grade, they know almost how to use almost every tool except for the table saw. But I should say that we use Saw Stop, which is very safe. The school does invest a lot of money in the tools. We use name brand tools, and we use the safest tool that's available in any category. So the teachers are trained. They have training throughout the year, okay? And then the students are trained in one-on-one training sessions with the teachers. So their skills by the time they graduate from high school are just amazing. They can use every tool in the room. They know exactly what they're doing, and they wouldn't dream of doing it without pulling their hair back, without putting their safety glasses on. So it's real clear to them, why it's always important to be safe. So.
And what does the typical training look like, just a session? So if you were, let's say, I think I've got a photo of a bandsaw here, but if you were to show me how to use this bandsaw here, what would you do to set this up?
Well, that's a drill press.
We will get a drill press. So if we were,
Okay.
we can just let that ride. So if you wanted to show me how to use a drill,
saw.
yeah, okay, the miter saw. Let's go with that.
Miter saw. So let's say that you were going to learn how to use the miter saw in a classroom. You would be in the 9th grade. Okay, so the first thing is, and I travel around with the teachers and sometimes get to enjoy doing the first 1 or 2 lessons with them. You talk them through why you would choose that particular tool for the job, which is really important because you've got a whole room full of tools, and the question is, why am I choosing this one and why am I not choosing the other one? So
very specific type of cut, very specific type of wood.
Exactly.
Not type of wood, but 2x4s generally.
Well, or anything that's, let's say, less than a foot, wide. But you do have the opportunity to slide, so you get a little bit more width out of that. But why do you choose the tool? Which tool you're going to choose, why you're going to choose it, what all of the capabilities of the tool are, like all of the controls on the tool, like what is this knob for, what is this button for. So we give them the first introduction, and then we teach them what they're supposed to do when they step up to the tool, like what should their appearance be like. I shouldn't have any dangling, anything dangling, like dangling jewelry or
anything that can catch on
or
the blade.
A tie, for example. Sleeves should be up, hair should be pulled back, and even the boys, you say, okay, if you look down and your hair is in your eyes, you need to pull it back. So what should you look like? What should the environment look like? You should look at the floor. There shouldn't be any sawdust for you to slip on. There should not be any loose tools or anything on the surface of the miter saw, for example. Shouldn't be covered with sawdust, so everything should be clean and tidy. You should use the clamp to clamp your wood down. So then you teach them the basics of the movements of how they would go through different cuts without electricity. And then they have to take an oral test where they have to name all the parts of the miter saw and what each one does. They have to tell you why they would choose that saw, why it's the best choice for a particular job, what jobs it's not good for. And then they have to be able to talk you through exactly how they would set up a cut, and then they have to take a written exam. And
before they ever touch the tool?
Before they get to touch it, but it's not plugged in, because they actually are going through the movement of using it. But their parents also have to give them permission to use it. But I should stress that, like we said, engineering, there's a big breadth of subjects that you study in engineering, and being a woodworker is not necessarily everybody's cup of tea. So you may have a student who says, I don't really want to do that, and that's quite okay. Let's say that they do need a piece of wood cut on the miter saw for a project they're building, then someone else can cut it, or I might cut it, for example. But it's not a requirement that they should step out of their comfort zone if they are afraid of large woodworking tools, because it's not everybody's cup of tea. And so there have been, over the course of 7 years, maybe 1 or 2 students who've said, I really don't prefer to do this. And our attitude is that is okay, because there are so many other things you can do in engineering. And then they might be perfectly comfortable with the smaller tools, which is super nice. So
I feel like it's the same principle as some students really don't want to dissect sharks.
Yes.
And sometimes they get exempted from the activity.
Yes, exactly. So, you want to work to people's strengths, and you don't want anybody to feel uncomfortable. And our teachers also go through rigorous training, and it's continuous training, because they would get rusty otherwise, to make sure that and we introduce new tools and new techniques. So they train during teacher work weeks. They have on-the-job training with us during the course of their school year as well. So they're very well versed in safety and how everything works.
I've sat in a lot of those trainings. You do such a good job developing those teachers to, just be a source of authority in the classroom, but a source of knowledge and safety standards for the students. So what you're doing as far as taking, Mr. Luddy's vision and sharing it across the network is just wonderful. Do you have a favorite tool, though?
Oh,
I bet as an engineer you'll say it depends on the job. Depends on what I'm trying to do.
It's so funny because when I'm doing working with the students with tools, the thing that always comes out of my mouth is, "Oh my gosh, this is my favorite tool," and I'll say it like 500 times. They're like,
I bet it's the shop vac.
Well,
That's my favorite.
They'll say, "Miss Tully, every tool is your favorite tool," and I say, I have the best job in the world because I get to test all the tools, and then I get to choose my favorites that they're super robust and really safe, and then we roll those out into the schools. So by the time they end up in the classroom, they are my favorite tools. They're all my favorite tools. So I love them all. And then my husband says, I know you love the saw stop, but we're probably not going to buy one. You do get that. So,
but if you had to choose a favorite,
I don't know that.
Table saw?
No, I would say that the one that I use the most at home.
Needle nose pliers.
No,
those are great.
It is actually the miter saw.
Okay.
I think that you can do most things with a miter saw. Table saw is a close second. Yeah.
I mean, crown molding, like if you can do that on your own, and miter saw plus a coping saw. What's your favorite woodworking project?
I like everything electric.
Okay.
Yeah, I'm an electric tool girl. I don't want to work too hard.
Yeah. Well, what's your favorite project that you've done then?
Me personally or students?
I mean, we can answer for both. I mean, at home, my favorite is some beadboard plus some nice molding that I put up in our hallway.
I designed a beautiful C-shaped patio couch. Oh. My husband is 6'3", and my goal was that we could both sit on one end of the porch and put our feet up and read a good book and have plenty of room. So I designed this beautiful C-shaped that just fit perfectly on my porch. And then my husband and I built it, and that's absolutely beautiful. But then we built a couple of just fabulous massive tool benches on casters that we move around our garage that you can just build anything on. Those are my two favorites.
Okay.
So yeah.
What about with students? Is it the 3D printer? Mine's the pancake maker.
It's impossible to choose because there have been so many wonderful projects. But one of the most beautiful things my students have done is if I was to pick something that I would have loved to just taken home with me, one of my students built a gorgeous Lazy Susan with triangular doors. It was really pretty. And then they built some beautiful bookshelves. I mean, there's just so much beauty in wood art. Oh my gosh, I would take them all home.
Mm-hmm. Well, I think we've got time for one more question, but what's your goal for students coming out of the Luddy Industrial Arts Program and the Luddy Institute of Technology, which really from 6th grade through 12th grade, we're trying to teach students the skills that they're going to need to make beautiful things and fix things that need fixing. What's your goal for the students going through that program, if you've got them from 6th grade up through 12th grade?
For me, I feel like we've been successful if they come out of it and they understand their potential. Mm-hmm. If they understand what they're capable of and they realize that there's no real ceiling to that, because with everything that we teach them technologically through Industrial Arts Program and Luddy Institute of Technology, you keep introducing them to, let me show you how to use a new tool, let me show you how to make this new electronic connection, let's look at this new way to program something. You keep pushing the ceiling a little bit higher about what they can learn. So by the time they get out of the program, I think they should feel like there's no ceiling. Like if they put enough thought and effort into it, they could pretty much do anything. And I think we're successful with that. And I think the introduction of the Luddy Industrial Arts Program has given us the opportunity to sort of tap into the desire of students to build and do these things at a younger age, and it just fuels them. I mean, by the time they get out of 8th grade, they can already do so much. By the time they graduate from high school, I mean, they can just do absolutely anything. Yeah,
and the learning curve when they get out of high school is going to be so much less too. Like they can do a little coding. Yep. People go to college to learn that particular skill, and yet they're getting this great just fundamental overview of coding. They can actually do projects by the time they get out of Luddy Industrial Arts.
And they're also learning in Luddy Institute of Technology. They're learning SolidWorks, which they teach at university to engineering students, and 3D printing. So if you just look at the fact that they've got their Python under control, they have the basics of electronics, they have their SolidWorks, they have their 3D printing, they have their mechanics, they have good tool skills. I mean, we've set them up for success, whether they go to trade school, whether they go to on-the-job training, whether they go into the military, whether they go to university, they are set up for success. And I think that is the goal. Set them up for success and make them realize that they can do absolutely anything they want to.
I love that. That is so good. Well, we've been speaking with Kim Tully, who's the director of our Luddy Industrial Arts program, the Luddy Institute of Technology. We'll include some links in our show notes to these really beautiful books, so that if you don't have access to, if you're not close by at Thales campus, but you want to implement some of these ideas, some of this curriculum, we can show you where to find these books online. They're available for purchase through Amazon, and honestly, free downloads, EPUBs, PDFs through Thales Press. Just email us, message us, comment, whatever we can do to assist you and your students in meeting these sorts of skills we want to do. Kim, thank you so much for being on the program again today.
Thank you for having me. It was a pleasure.
And thank you so much for listening to this episode at home. If you're interested in our program, the Luddy Industrial Arts, Luddy Institute of Technology, or in the unique brand of classical education that we have here at Thales Academy, please be sure to check us out at our website at www.thalesacademy.org. And for developing classical thinkers, I'm Winston Brady. Until next time, stay classy and stay classical.